Unit 4, Introduction to Functions. Today we're going to take a look at 4.1, Relations and Functions. So our new vocab consists of a relation is a set of ordered pairs, and I've given you an example of what that looks like. The domain are the set of x values in a relation. The range are the set of y values in a relation. A function is a relation in which each domain is matched with exactly one range value. I've also given you an example of a relation that's a function underneath. Relations occur all around us. In many naturally occurring phenomena, two variables may be linked by some type of relationship. For instance, the height of a plant is related to the amount of time it has been growing. The table below shows the relationship between the height of a sunflower over time. We can take a look at this as a set of ordered pairs, which is a relation. And if I pull out the domain values, that would be my x values, 1, 2, 3, 4, 5. So my domain for this relation is 1, 2, 3, 4, 5. And the range is going to be my y values, which are 6, 18, 30, 22, and 54. There are many ways to represent a relation. So I've given you a set of ordered pairs. I could place them in a table. I could graph them as ordered pairs, or I could put them in a mapping diagram, which looks like this. Keep in mind that when you're doing the mapping diagram, you can have no duplicate numbers. So each number must occur only once, either as an input or as an output. So let's try a few of these. So I have a relation that has 3 parts to it. I can graph it. So 0, 0 is the point right here. Negative 3, 2 is right here, and 4, 4 is here. That's one way to represent this relation. I could put it in a table of values, 0, 0, negative 3, 2, and 4, 4. I could put it as a mapping diagram, 0, negative 3, and 4, 0, 2, 4. Make sure that you have arrows that connect the input to the output, the x value to the y value. And I can also isolate the domain and range. The domain in this case, 0, negative 3, and 4. My y values, the range, are 0, 2, and 4. So how do we determine if something is a function or not? Well, if we're given a set of ordered pairs, we're looking at the domain. We're looking at the x values. So for number 1, I have 2, 3, 5, and 4. My x values are all different, so this is a function. In example 2, this is not a function because if I take a look, I have 5 with 2 different outputs. I have the domain value of 5 that has 2 range values, so this makes it not a function. In example 3, if I look, I have 0, 1, 2, 3, 4. Each of my x values, each of my domain values are different. And notice, even though all of them go to the same range values, it's still considered a function because each input has only one output. Given a mapping or a table, write it as a set of inputs and outputs. We're going to look at the arrows off of the input. So for example, in this relation, I have the values 1, 2, negative 3, and 1. Notice when I put it in the mapping, though, I only write the number 1 time. My range values are 3, 4, 5, and 6. So I'm going to pair these up by connecting arrows from the input to the output. So 1 to 3 is my first ordered pair. 2 to 4 is my second ordered pair. Negative 3 to 5 is my third. And my fourth one is 1 to 6. Now, as soon as I have a second arrow coming off of one of the input values, I do not have a function because, in this case, 1, the input, has 2 outputs. In this mapping diagram, I have negative 2, 0, 2, 4 as my domain values, 6, 4, 2, and 0 as my range values. Notice that I've paired them up with arrows. So negative 2, 6 is paired up this way, 0, 4, 2, 2, and 4, 0. This one is a function. There are no duplicate x values, or each input has only one output. The last thing we're going to look at is how do you look at a graph and decide whether or not it is a function. It must pass the vertical line test. To pass the vertical line test, a relation must only cross any vertical line one time. So my first relation is a function, because no matter where I draw a vertical line, it will only cross in one location. Crosses once here, crosses once there, crosses once there. So this is a function. A parabola is also a function, because no matter where I draw a vertical line, it will only cross that relation in one location. However, a circle is not a function, because almost any vertical line I draw is going to cross in two locations.